Hey everyone, this is Scott from QuickBOM, and today we're going to be going through some advanced features of QuickBOM. This is where the tool really starts to become powerful as a way to manage indented BOMs right in Excel. If you haven't already, please watch Tutorial 1A for instructions to manually create a BOM, and Tutorial 1B for a guide to import a BOM from SOLIDWORKS or any other CAD system. We'll be using skills from both of those in this tutorial. We'll be reviewing this 5-jaw pneumatic gripper as an example. You can download this assembly if you'd like to follow along yourself. There are a few interesting things to note about this. Number 1, there's actually two configurations in this assembly, a 5-jaw version and a 3-jaw version. We'll treat each one as its own BOM, but they each share a lot of common components. 2. There are some modeled parts that are excluded from BOM. If you click on this blue polyurethane tubing, you'll notice that it's got a ref in front of its name. Right-click and go to Component Properties and notice that Exclude from Bill of Materials is checked. Parts like this polyurethane tubing, other pneumatic components, and all electronics are not modeled and therefore not included in the BOM that SOLIDWORKS creates. Instead, we'll build those as manual BOMs, and QuickBOM will merge them into the CAD-controlled BOM. Take a look at this Kits folder in the design tree. By default, we're going to include a sensor kit, a valve kit, and a spare parts kit with each gripper. If you open up any of these part files, notice that there's no geometry. That's intentional. We'll talk about why a little bit later. So let's go ahead and get our BOMs into QuickBOM. Like I mentioned, we'll treat each configuration as its own BOM. On the Instructions tab, click Create New BOM. Select CAD BOM and name it Gripper 5-Finger. Now do that again, but name the next tab Gripper 3-Finger for the other configuration of the gripper. Let's also create a manual BOM tab for all of the pneumatics and electronics that don't get modeled. We'll call it Gripper Options. Let's tackle this manually created BOM first. Normally, I would have my engineers building a manual BOM in parallel with the SOLIDWORKS design process. Anytime they identify a part that doesn't need to be modeled, they would add it to the manual BOM. For the sake of this tutorial, I'm going to paste all of this information in. I have a file ready called Gripper Options for Copy-Paste, which you can download from the link in the comments. Before we paste in data, we're going to disable sync. You'll want to do this anytime you do some serious surgery on any of the indented BOM tabs. Sync refers to the collection of macros that keep the library and all of the indented BOM tabs in sync. If you make too many changes at once, the sync function will try to account for all of them at the same time and it'll trip over its own feet. Once you make your changes, you can turn sync back on and the sheet will catch up on its own. So let's copy the information from the other file and paste it into man_gripper options. Then we'll click Enable Sync in the top left of the sheet. QuickBOM will churn as it works to load every part and its data into the Library tab. Once it's done, we'll notice that some of the formatting is a bit off. Click Sheet Controls and click Recalculate and Reformat All Cells. If the cost data isn't showing up with $signs, highlight those columns and reformat them too. There, that's looking better. Let's pause to look at what's in here. There are two sensor kits, NPN and PNP. These sensors clip onto the side of the cylinder to sense whether it's extended or retracted. Depending on a customer's setup, they might need NPN or PNP. There's also a spare parts kit, which contains replacement seals and a spare solenoid cable. Lastly, there are two solenoid valve kits, one that runs on 120 volts AC and one that runs on 24 volts DC. A quick glance through the list makes me notice that each kit is very similar, but not identical. For example, they both have the same air tubing and push-to-connect fittings, but they have different relays and different solenoid valves because of the different voltage. If we look back at the CAD file in the kits folder, we'll notice that there's one NPN sensor kit, one 24 volt DC valve kit, and one spare parts kit. Having these in the CAD managed BOM will pull in information from the manually created BOM, and you'll see this later in the process. Now, let's work on creating a BOM for each CAD configuration. Activate the 5-finger configuration. Select the 5-finger BOM and save it as an Excel file. Activate the 3-finger configuration and rebuild it to make certain that the BOM table is updated. Select the 3-finger BOM and save it as an Excel file too. Now, we'll copy and paste them into their import tabs. Finally, we're ready to import. We could do this BOM by BOM by clicking Sheet Controls and Import. Instead, let's do both BOMs at once. Go to the Instructions tab and click All BOMs: Import from CAD and sync all BOMs. Follow the prompts and watch QuickBOM do its work. Each part will get an entry in the Library tab, and each CAD _ tab will become a structured BOM. In the QuickBOM file, there's a lot of tabs now, so let's hide some of the ones that we don't need anymore. On the Instructions tab, let's click Hide Import Tabs because we won't be needing them for a while. Now, let's take a look at Gripper 5-finger. We'll take a look at the structure for a bit. I'm going to click on Sheet Controls and minimize all groups. Notice that this matches SOLIDWORKS exactly. I can expand Assemb Hand 5-finger in QuickBOM and in SOLIDWORKS and I'll see the exact same things. And I can drill all the way down until I find whatever I need. If I flip SOLIDWORKS over to the 3-finger configuration and go to the 3-finger tab of the Excel file, I find the same thing. Everything is identical all the way down, except for these kits. The only difference between SOLIDWORKS and what's in QuickBOM is these kits down here. If I expand one of the kits, I notice this yellow patch of cells. Everything in yellow was pulled from your manual BOM. This is a key feature of QuickBOM. You can create manual BOMs full of parts that don't get modeled in CAD, such as wires, hoses, and electrical components. Just include the top level part number as an empty part file in your CAD model, and all the manually created parts will get pulled in. You can also do the opposite and create a CAD-driven BOM that gets pulled into the manual BOMs. Importantly, the same parts can be in the CAD BOM and the manual BOM. Just look at this part MC-788 in row 47. This is a push-to-connect fitting for the pneumatic airlines. This is contained both in the manual BOM and in the CAD model. The same part and the same data records are common between them. The more you use this system, the more you will find opportunities for this feature to get you out of an edge case while designing. Now, let's imagine that your cost information comes from a different system, like your ERP system. In my day job as an engineering manager, that's the way my company operates, so I've come up with some tricks to merge that external information into QuickBOM. Let's say that you ask your purchasing partner to go out and get quotes for all the purchase parts, and he comes back with this Excel file. It's great and well organized, but it's on its own little island. So let's try to merge it into QuickBOM. You're going to do all of this on the Library tab. Let's get both documents where we can see them, and we'll be using basic Excel formulas to pull in this information. In this case, I'm going to create a few new columns where I want this to go. And when you do this, it's recommended to indicate that these are custom attributes by typing custom in the cell above. I'll be using a VLOOKUP formula like this. And then I'll copy and paste it down the list. And then I'm going to repeat that for the attributes cost, manufacturer, and manufacturer part number. Once done, I'm going to highlight everything, copy and paste as values to kill off the formulas that pull information between files. I personally have followed this process to pull in stock quantities, lead times, minimum order quantities, vendor terms, and anything else that I might need to advise buying decisions and BOM management. Let's flip back to the indented BOM tabs and notice that the cost for everything has been updated. The sheet automatically calculates a cost of $1,159 for the 5 gripper version and $1,030 for the 3 gripper version. In my job as an engineering manager, I like to use this process to track cost as we go through the design process. That way, I can get a pretty good vision of where our total cost will be when all is said and done. I've also seen engineering teams store cost information in the custom properties or the data cards of their SOLIDWORKS parts. This is another effective way to manage cost, and QuickBOM can pull in that information and come up with subtotals just the same. Now, imagine that your VP of Marketing brings you the sales projections. The company thinks it will sell 3,000 of these grippers next year, but that is broken up into 2,000 of the 3-jaw version, and the other 1,000 as the 5-jaw version. How many of each part should purchasing buy in preparation for next year? Let's calculate it. We'll use flat quantity in CAD gripper 3-finger, and flat quantity in CAD gripper 5-finger. You can trust these numbers to be the quantity that you need to build one gripper. Let's create a new column to store the calculation. We'll call it EAU, short for Estimated Annual Usage. Type custom into the cell above it. And we'll write a formula that is equals flat quantity 3-finger times 2,000 plus flat quantity 5-finger times 1,000. And we'll drag down the formulas. This is how many parts we'll need this year, taking into account that we're going to build more of the 3-finger version than the 5-finger version. If we had the current stock levels in this sheet, I would incorporate them into the formula and really get a granular view of how many we need. Now, let's calculate the total value of those parts per year. We'll create another column called Total Value and calculate it as equals EAU times cost. In my job as an engineering manager, I find myself referencing this very column a lot. I filter and sort for the highest value items, and that's where I have my engineers focus their cost reduction efforts. With all this information that we built into the Flat BOM library tab, it's good to refresh our minds that we can pull any of this information back into the indented BOM. Let's flip over to CAD Gripper 5 Finger, and we'll add in a total value column. Click Sheet Controls, Insert Column Header, Custom, and select Total Value. A quick word about searching. If you want to find a part but you don't know its part number, you might use Ctrl F to search for it in the descriptions. Let's do that right now for the search term wire. It finds nothing. Why is this? There are two possible reasons. Number one, Excel won't look through cells that are hidden. Before you search, you'll need to get into the habit of going to Sheet Controls and clicking Expand All Groups. Number two, Excel by default searches through formulas, but we want it to search through values. You'll have to get into the habit of telling it to look in values with this drop-down box here. Now, a quick search for wire reveals that we are speccing this specific 18 gauge black wire, and we're using approximately 10 feet per machine. That concludes everything in the advanced training. You now know how to handle CAD assemblies with configurations, how to create manually created BOMs, how to merge CAD-driven BOMs and manually created BOMs, how to import data from other systems like your ERP or price lists, how to calculate custom attributes like estimated annual usage, how to filter and sort data in your library tab. That's your Flat BOM. How to create and remove custom attributes from parts. How to search for parts throughout the sheet. If you have other features that you wish were included in QuickBOM, please message us at quickbom.com/contact us. We're constantly building and tweaking the software to work for more and more unique design scenarios, and we'd love to include yours.